This is very interesting problem. Often the students give the wrong answer. The transformation of oxyhemoglobin to deoxyhemoglobin. What happens to the oxidation state and spin state of iron? Here oxyhemoglobin to deoxyhemoglobin. Let us represent oxyhemoglobin like this. This is porphyrin ring. In the middle I have Fe2 plus. At the bottom there will be histidine. The nitrogen of histidine will bind to this. Here oxygen molecule. This is oxyhemoglobin. In this, the 4 nitrogen atoms and Fe2 plus, they are in the same plane. This loses oxygen molecule, and what we get is deoxyhemoglobin. In the tissue or in the cell, this transfer takes place. This will be vacant. The 6th site will be vacant. Here the Fe2 plus atom will be in different plane. In the previous case, 4 nitrogen atoms and iron, they are in the same plane. But here this will be somewhat above and they will not be in the same plane. What about the oxidation state of iron? In oxyhemoglobin as well as deoxyhemoglobin, the iron will be in +2 oxidation state. +3 oxidation state is not useful for oxygen transport. There is no oxidation or reduction during the binding of oxygen to Fe2 plus. In hemoglobin, we have Fe2 plus that can carry oxygen. If you know that, you can eliminate 2 options easily. What about the spin state? I mentioned in oxyhemoglobin, Fe2 plus and the 4 nitrogen atoms are in the same plane. But here Fe is in different plane. It is somewhat above because the size of Fe2 plus will be somewhat larger and it cannot be accommodated in the cavity. What is the reason? In deoxyhemoglobin, when oxygen is not attached to Fe2 plus, Fe2 plus will be in high spin state. It will be D6 system. If you place the 6 electrons in 5 orbitals, there will be 4 unpaired electrons. So this is high spin system. Once the oxygen is attached to Fe2 plus, the pairing takes place. Again it is D6 system, but it is low spin complex. When it is low spin, the size of Fe2 plus is decreased to some extent and it becomes somewhat small and the size is suitable to be accommodated in the cavity. That happens only when oxygen binds to Fe2 plus. So when oxygen is bound to Fe2 plus, the size of Fe2 plus decreases due to pairing. Now let's go to the options. Fe2 plus in the low spin state changes to Fe2 plus in the high spin state. Low spin to high spin. This is the correct one. What about the third option? Fe2 plus in the high spin state changes to Fe2 plus in the low spin state. Generally, the students do not understand the question clearly. In the question, it is given oxyhemoglobin to deoxyhemoglobin. But student, they take it reverse. Generally, they consider this as reactant, this as the product. If you consider like that, this will be the correct answer.